Okay, so here we are on another method for we've been solving systems of equations. We're talking about linear equations in Unit 4. And we have this second method. So we already learned graphing, and you guys can remember we identified for graphing, we identified the point of the beginning point, and we did our rise and run and all that stuff. Well, we're going to use a second method here in our notes, and we have the time when substitution is best used when we have one variable solved for either y or x. So let's take a look at page 2 in your notes. Method 2, solving systems by substitution, and then later on we'll learn method 3, solving systems by elimination. So here we have an equation 7x plus 10y equals 36. So we have a linear equation. Linear means a line. Typically we have an equation, this one's in standard form. It could be ax plus by equals c. We call that standard form. Oftentimes we'll have one in slope-intercept form, y equals mx plus b. So we have, see how there is an x and a y and an x and a y right there? This is slope-intercept form. Okay, so to use substitution, either an x or a y has to be isolated. So is either equation solved for x or y? Another way to say that is y or x isolated? Okay, and if we look at this, we have a 7x, that's not 1x. We have a 10y, that's not 1y, that's a problem, equals 36, a constant. Over here we have negative 2x, so that's not solved for x. We have a 1y right here, but it's not isolated, it's not all by itself, equals 9. So is either equation solved for x or y? And the answer is no. So we're going to pick the easiest variable, x or y, in one of the equations to isolate. Okay, so we need to isolate. So that's why in Unit 2 we spent so much time isolating. We had to use inverse operations and other things. So that's a Unit 2 review. I can solve this for y. Now the problem with the left side here is that I need to get rid of this minus 2x completely. I can't just move it from the left to the right because this thing is balanced. So I have to undo the minus 2x. How do I do that? Oh, okay. Well, I can do that if I add 2x to the left, because minus 2x plus 2x is 0x. Now the problem is I've added 2x to the left, so I have to travel across the equal sign to the right, and I can plus 2x. Notice that they're not in the same column because this number is a constant, so I'm going to leave it here, and this number over here is a variable term. Okay, so those are not alike, and we don't add them together if they're not alike. You can't sum these together. You cannot add these to be 11x. This is not 11x. This is a 9 plus 2x. Now I can, under the commutative property of addition, I could write the variable term first. So that's what's better here, to write the variable term first and then the constant. Okay, so now I have it isolated for y. So I have, this was equation 2. Okay, so I have a value for y. The value of y is 2x plus 9. I'm going to go use the other equation. I'm going to use equation 1, which is here. Here's equation 1. Notice it's 7x plus 10y. Okay, I'm going to circle this y right here. Equals 36. The reason I want to do that is because I have a value of y in terms of x. I can't solve for two different variables, but if I can make it all one variable, then I can solve. So I have equation 1 down here, 7x plus 10y equals 36, and you can see that I'm going to replace y in equation 1. I'm going to replace it with this thing, 2x plus 9. And that's what you see right here, 2x plus 9. Okay, so now I'm back to, this is simply unit 2 stuff again. I have all of it in one variable. Okay, so what did I do again? I isolated equation 2 for y, then I took the other equation, and where I saw y, I put in 2x plus 9. So now I can solve this. I have to do and follow all the rules though. So now I'm solving it for x. Okay, so what are the rules for solving an equation? We have the distributive property. That means multiplying, and we do that by drawing an arrow, making sure we multiply the 10 times the first term inside the parentheses and the second term. We have 7x. Now we're going to do some multiplication. 10 times 2x is 20x. And then 10 times 9 is plus. Make sure you check your signs. That's plus and plus, plus and plus. So these ended up being both positive. All right, so now we have, oh look, some variable terms are alike on the left. So I'm going to combine them. Combine like terms. 7x plus 20x. I just do that. I could do a little V right here to show it's going to combine, little two arrows or something. I combine them together. Now if they were different signs, then I would have to do some subtraction, but they're both positive signs. That came out a little bit ugly. I'll just white it out really quick so it's not so ugly. And we'll go 27x plus 90. Okay, now I'm down to two-step equations. Two-step. All right, we know that we want to get x by itself, so we're doing inverse operations. We do the additive inverse first. And we focus on the constant here because we're getting x by itself. This 9 plus 90, how do I get rid of that? I subtract. Oh, I see from this, you could, well, we'll do the additive inverse here. You could just simplify first. And we could do that by dividing both sides by a common denominator. Let's say we divide everything by 9. Okay, we can do that. 27x divided by 9 is 3x, so we could do a little simplification. 90 divided by 9 is 10. So we have, remember they're sharing this. When you divide the left side, you have to divide the entire left and the entire right. We have 3x plus 10 equals 4. Now we're going to do the additive inverse. We want to get rid of this 10 by subtracting 10. We slash out the additive inverse. We're just left with 3x equals negative 6. And we do the multiplicative inverse, or divide. If it's constant, we can divide. Or you could have multiplied, if you had 3x equals negative 6, you could also multiply by 1/3. And you would get x equals negative 6 over 3. We do this when it's a fraction, which equals negative 2. But when the coefficient is a integer, we just divide by 3, and we get our x equals negative 2. We're almost done at that point. We have a value of x. Now we just need to find what y is. We could pick either equation, 1 or 2, and then we'll just substitute the negative 2 wherever we see x. So let's pick one of the equations. Well, we had solved one of the equations for y right here. Y equals 2x plus 9. So we now know what x is. And now we're going to replace y equals 2, and in place of x we can put negative 2. Okay, so we have negative 4 plus 9, which is positive 5. And then we make sure we write our answer as an ordered pair. Always have to write your answer as an ordered pair, and then you're done. Okay, so let's take a look at what that might look like in your problems. Let's go to problem number 3, and we can see that, oh boy, this problem can be quickly solved for y in equation 1. Now equation 2 is going to be a little bit harder. So let me do the slightly more difficult one here, where we are solving equation 2 for y, for problem 4. Let's do problem 4. Equation number 2 is 4x minus y equals 2. I'm going to solve it for y. There's two ways to do it. I could subtract 4x from both sides, or why don't I just add y and move it over to the right? Otherwise, I could subtract 4x from both sides and multiply by negative 1, but here, this might be a little easier. And why don't I subtract 2 while I'm at it? And I get negative 2 plus 4x. This was positive 4x. And this went away. So now I have it solved for y. Very quickly and easily, I have my solution. Remember, I used equation 2. Now, in substitution, you have to use the other equation. So let's do equation number 1. I'm just going to put a little quick orange highlight here. And I have equation number 1. Let's write it down. 2x plus 5y equals 12. And I'm going to highlight y because that's what I'm going to substitute for. So I'm taking what I solved, equation number 2. I solved it here. I'm going to place it in place of y. And I get 2x plus 5. Now, in place of y, I'm going to use a parentheses because I have to distribute. I'm replacing y with negative 2 plus 4x. And then that equals 12. Okay? Remember, we distributed. And I got 2x. 5 times negative 2 is negative 10, so I have minus 10. 5 times 4x is positive 20x equals 12. These are my like terms. 2x and 20x is 22x. I can't, this is a constant. I cannot. Okay, we're getting close. I'm going to add 10. Getting tight on space here. And I have 22x equals 22. So I'm going to just draw a little line to go over here where I have more room. 22 times what is 22? Well, that means x equals 1. So then I can pick either equation. Now this equation number 2 is solved for y, so that would be the smart one to use. So I'll go negative 2 plus 4, and in place of 4 I'm going to use I know that the value of x is 1 now. So I'm going to put 1 in there equals y. So I just use this equation. Negative 2, 4 times 1 is 4, equals y. Negative 2 plus 4 is equal to 2. It wouldn't make any sense if you had negative 2 plus 4 equals 6, right? That would be not smart. Okay, so I have my x and I have my y. I just got to write my answer or my solution. My solution is x is 1 and y is 2. Okay, so then that's your x and y. I need to go back and I can check my answer. How do you do that? I'm just going to put 1s and 2s in for x's and y's. So I'm just going to go check, and I'm going to go 2 times 1 plus 5 times 2. Does that equal 12? 2 plus 10? Yes. How about here? 4 times 1 minus 2 equal 2. 4 minus 2 equal 2. Check, check. Okay, so that leaves it the last equation. Now, Here, the smart thing would be to solve equation number 1 for y. Well, it's written right here. Easiest to just solve equation number 1 for y. And then substitute into equation 2. So you'll do problem 3 on your own, following these steps, and then you'll turn that in to Google Classroom with an image.